Hello everybody, welcome to Math 1710D, Calculus 1. This is the very first lesson and we're going to talk about some prerequisite materials. But before that, I'd like to take just a little bit of time to talk about the nature of these lesson videos that I'm creating. The purpose of these lesson videos is to supplement the course material. It is not my intention to cover everything like a blanket because that kind of resource is already available. Specifically, I'm talking about these. Here we are in WebAssign class page. This is a home page in WebAssign. And all these assignments, announcements, everything will be activated once the class begins. I'm recording this sometime in June, so not everything is ready yet. Now, if you go over to lower left-hand side corner, there is resources, and then we have textbook information here. Calculus, Early Transcendentals by James Stewart, 7th edition. If you click this, and then we'll have book resources, and we have all those chapters. Click any chapter and we'll have lecture videos on each section. These lecture videos created by the textbook's publisher cover everything like a blanket. So if you're interested in the course materials and if you do not want to miss anything, please go ahead and go through these videos and they'll be helpful. Now, the purpose of my lecture videos or my lesson videos here is a little bit different. I'm not trying to cover everything like a blanket. Instead, what I'm trying to do is emphasize and de-emphasize appropriately. There's some kind of topics that I regard more important than the others, and there are some topics that I regard less important than the others. And those will be reflected in exam problems and so on, and there should be some way to convey that to students in online environment, and that's why I'm doing these. Also, I'm going to talk about some shortcut method here as well. In general, the shortcut methods are big no-no in the publisher's lesson videos or anything in print, because very often they are not always correct. Well, in print you have to stick to the kind of method that works all the time and 100% correct. In classroom we can talk about some shortcut that works a lot easier for some special situations, but flat out fails in some other situations. There are drawbacks, yes, but then again, in my experience, majority of the students benefited from these shortcuts. Okay, enough digressions, and let's talk about the prerequisite materials now. I divided this lesson into 3 sections. Section 1, Algebraic Preliminaries, Section 2, Geometric Preliminaries, and Section 3, Analytical Preliminaries. Section 3 is the real one. It roughly corresponds to the chapter 1 of our textbook. Students who feel very confident with first 2 sections, algebraic and geometric preliminaries, which will be about college algebra level or below, then they can just move on to the video in analytical preliminaries. For the other students, let's go. Let's begin with the set notation. What is a set? It's a collection of objects so that whether a certain object, certain candidate is an element of a set or not should be definite. There are 2 ways to represent a set. That is to list everything. If there's pattern and there are infinite sets, you can use ... Also, you can use conditions, a set builder notation, that is. There are some notation about elements, not elements, subsets, and not subsets like these. Okay. There are some special sets that we'll use very often. NWZQRC with double stroke font. Those represent the natural numbers, whole numbers, integers, and so on. Another kind of sets that we use very often are intervals. We have brackets that is associated to semi-inequality, and parentheses that is associated to strict inequality. Okay, let's go over to some basic algebra. Equality literally means equality. That's no joke. I've seen some mistakes like this, even in calculus level, believe it or not. 2x plus 1 equals negative 3, so flip this one to the other side and get negative 4. Divide it by 2 and then you get negative 2. That's an answer, right? Correct answer, but wrong algebra. Look at this part. Negative 3 minus 1 equals a negative 4 over 2. The left-hand side is negative 4, right-hand side is not. This equality in the middle, right over here, is wrong. And in college algebra, in this kind of algebra, mistake with correct answer used to count something like 30%. I used to give 33 out of 10 in college algebra. But in pre-calculus and calculus, of course, they count nothing, 0 credit. Another kind of mistakes that I see relatively often is misusing parentheses. Here's an example. If I have to calculate f of x minus g of x like this, you have to open a parenthesis and you have to close it. You cannot just abbreviate without parentheses and then hope for the best later, because very often you're going to make another mistake because of that. Even if you do not make mistake and get it done correctly in the end, you will still lose some credit out of doing these. How do you do it? How do you do it right? Well, open parenthesis and close. When you distribute a coefficient, circle entire number, highlight entire number, including the sign, because sign is a part of the next number, and distribute negative 3 times x squared, negative 3 times 3x, negative 3 times negative 2, and then we get these numbers. Afterward, you can't miss it. Okay. Another kind of mistakes that I see relatively often are breaking up parentheses or square root, or sometimes even fractions incorrectly. You simply can't do these. Here are a couple of examples. Wrong solution. X minus 1 total quantity squared is not x squared minus 1 squared. Even this middle is plus. No. You have to use complete square. Either you FOIL it or use complete square formula. It doesn't matter. You must have this middle part. The second problem concerned misusing square root here. You cannot separate the square root. You can't. What do? Oh, by the way, let's open it again. You can't separate it. This first line to second part is wrong. How do you work it out? Well, isolate the square root and then square both sides, of course. Okay. And then let's move on to another kind of mistakes that I see. Okay, not as often as the others, but I've seen even in calculus level. If you have quadratic equation, well, you can factor it, but the right-hand side is important. You cannot just ignore as if there was nothing there. It is important to keep the right-hand side equal to 0, because once you factor like these, we have factor A times factor B equals to 0. Consequently, we have A is equal to 0 or B is equal to 0. there's no way you can get 0 by multiplying two non-zero numbers or any number of non-zero numbers. One of them has to be 0. That's why the factorization works out when the right-hand side is 0. Otherwise, it's useless. Now let's move on to intermediate algebra. Some expansion and factorization formulae are explained over here. By the way, this notebook is posted in Blackboard. Complete square formula, square minus square, and then how to factor quadratic trinomials. And there's some more formulae hidden, not as important. Not unless you're an A student who wants to cover everything like a blanket. Okay, here we go. Important point here, zeros and their multiplicity. If you have a polynomial function completely factored, then you can set this factor equal to 0. Then what do you get? You get first factor equal to 0, second factor equal to 0, all the way up to kth factor equal to 0, because there's no way we can get 0 by multiplying a bunch of non-zero numbers. Consequently, x minus c1 equal to 0 gives us x equal to c1, and so on, all the way up to x minus ck equal to 0, consequently x equal to ck. These powers are called the multiplicities. Why are those multiplicities so important? Because the local behavior of this polynomial function around that 0 behave pretty much like a power function with the same multiplicity, same power. Let's look through it through the following example. F of x is 2 times x plus 3 squared times x cubed times x minus 2 is greater than 0. So we want to find out the intervals in which this function f of x is above the x-axis. How do we find it out? Well, if I set them equal to 0, here it is. X equals to negative 3, x equal to 0, x equals to 2 from the third factor, and then look at the multiplicities. 2, 3, and 1 respectively. And then I highlighted blue for even multiplicity and red for odd multiplicities. Now, what are their roles? If you plug in some large number, like x equals 100 or something, or even better, infinity, then all these are very, very positive, so clearly positive. Now, when x hits x equals to 2, the function value becomes 0, which means graph goes down to 0 and then hits this 0 right over here. And then what happens next? X minus 2 has first power here, so this graph behaves kind of like a linear function, first power function. So graph cuts through the x-axis, kind of like a line around here. Now when x is pretty close to 0, it behaves kind of like a cubic function, third power. So it goes up and then hits the 0 and then cut through, kind of like cubic function. So we have a sign change again. And now when we have even multiplicity, now power is second power. So we have a behavior like a quadratic function. Positive here, and then hits the x-axis and then bounces back. More specifically, I'm talking about this graph here. As you can see, at x equals 2, we have a crossing, so we have a sign change, plus becomes minus, and crossing is kind of like linear, and at x equals to 0, crossing is kind of like third power function, and at x equals to 3, we have hit and bounce back, pretty much like a second power function, a quadratic function.